Welcome back, guys, to Not a Napkin Science Chat. Welcome back, guys. Today we are going to be discussing the benefits, the cost, and the mechanisms involved in overall how nuclear fusion energy is generated. We'll also be looking at a real nuclear fusion reactor.
Fusion is what processes the sun that you see every day. Fusion is what allows life to thrive on planet Earth, and it seems that the sun is virtually an unlimited energy. But wait, how does the sun do that?
Oh, I'm glad you asked. We will travel into the center of the sun to see how the sun generates all of this energy. Wow, it's warm in here. In the center of the sun, extreme heat and pressure strip the atoms of their electrons, making a plasma where electrons and nuclei move around freely. This allows for two hydrogen nuclei to merge and form a helium atom. During this merger, some of the mass is converted into energy, which is why the sun glows every day and allows life to thrive on planet Earth.
Now that we know how fusion works in the sun, how is fusion recreated on Earth?
Well, for that, we must go inside a real nuclear fusion reactor.
This is a nuclear fusion reactor. It's called a tokamak. It contains a torus similar to a shape of a donut. This is used to generate energy from fusion among many other things. There are various different types of reactors. However, this donut-shaped reactor is one of the best reactors. For the reason, the torus-shaped reactor allows the plasma to be confirmed by high-temperature superconducting magnets, which prevent the walls from melting due to extreme temperatures and plasma inside the reactor.
Now you might be asking, how is actual usable energy generated from a fusion reaction?
Well, the heat from the reaction is used to evaporate the water in the walls of the reactor. The steam from the water is used to power steam turbines, which in turn generate electricity. We are going to take a quick break, and I'll see you guys soon.
Now we're going to be seeing a heated pros and cons debate about nuclear fusion between fierce competitors, Sam and Wasi.
The demand for energy will have tripled under the combined pressure of population growth, increased urbanization, and expanding access to electricity in developing countries. The challenge for fusion energy is to create those conditions on Earth in a controlled way that can be used to provide power. The majority of the world's energy is currently derived from the burning of fossil fuels. Fossil fuels are a limited and non-renewable resources, meaning the world will eventually run out. Nuclear fusion is a very promising source of renewable energy for the future. The pros for nuclear fusion energy are: it's clean energy, there's no greenhouse gases emitted, virtually limitless fuel available, the deuterium can be distilled from seawater and the deuterium can be brought into the reactor. There will be no chain reaction, it's easier to control and stop instead of than nuclear fission. There's little or no nuclear waste remaining, and the price for the fuel is very low.
There are many reasons why nuclear fusion cannot be used in today's world. The first big problem is that fossil fuel workers will be unemployable. The skill set needed to work with fossil fuels is different than the skill set needed to work with nuclear fusion. As a result, this will cause havoc in oil-dependent economies, of which there are many in the world. Second, there is low incentive in the most powerful country in the world. Their president doesn't even believe in climate change, so there's no reason for them to switch over to nuclear fusion from coal, oil, petrol, gas, etc. Third, the technology has not been tested on a commercial scale. There are many potential unknown risks we haven't heard about yet. Fourth, there is a large development cost. Many countries cannot afford the amount needed for research and development into nuclear fusion. The money which would normally go into research would be better used in renewables such as wind, solar, hydro, because these infrastructures have already been developed. By far the biggest problem is you need more energy to create the heat that is needed for the reaction than is actually produced for the nuclear fusion reaction. This is counterintuitive because we're putting more energy in than we're gaining back. Enough about me, on to MC with C, Canal Simone.
You was on some trash shit. Nuclear fusion's garbage. Drive it out of here.
Big, renewable boy. Now let's not waste our money, B. Nuclear fusion gamble. We don't want to take it.
We want solar, B!
It is a total waste. This isn't a freaking game. We only have one chance to stop climate change.
This ain't a freaking party. Let's invest it smartly. Choose renewables, let's not choose nuclear energy.
Guys, I've been able to sneak into Area 51. This place is full of new stuff and dangerous people. If I get caught sneaking in here, they will kill me. They have all types of new technologies. Right now, behind us, I'm looking at a new nuclear fusion reactor. Nobody has been able to do this. This is a working nuclear fusion reactor. These people have fused hydrogen and boron instead of the regular hydrogen isotopes to make a fusion reaction. They also use high temperature superconducting magnets to keep the plasma from touching the walls. Oh my god, guys, this is some next level stuff. The people here use liquid metal for the reactor walls, as it allows energy to be absorbed from the reaction, along with protecting the inner walls of the reactor. Steam-powered pistons are used to compress plasma and heat it up in a more efficient way. Oh my god, guys, I think I'm hearing footsteps. I think someone's coming for me.